It's nice seeing you once again. You are welcome. Hope you are doing well. In our earlier days in primary school, carried out simple arithmetic where we'll be asked to divide certain numbers. There are numbers that we divide, it will exactly divide. For example, we say 4 divided by 2, we know it gives us 2. We say 16 divided by 4 gives us 4. But there are numbers that we divide, like 5 divided by 3. It will not give us an exact result. It will be 1 remainder 2. I remember when I was in primary school, when I meet divisions like this, I get very angry because I don't like them. But you know that this remainder is a powerful tool in mathematics. Yes, this remainder, you see, can help us predict some things accurately. And that is why today our topic is modular arithmetic. Looking at concepts of modular arithmetic. Yes, you heard me right. This remainder value can tell us a lot of things, saving us a lot of headache in very many areas in mathematics. Modular arithmetic finds use in mathematics itself. It finds use in computer engineering. It also finds use in cryptography, and also find use in our daily activities of life, as we are going to see soonest. Now, what is modular arithmetic? Modular arithmetic is a kind of arithmetic where positive integers, let me write this on the board. Modular arithmetic is a kind of arithmetic positive integers are added by rotating them in a number cycle. Yes, this is one definition of modular arithmetic. It is a kind of arithmetic where positive integers are added by rotating them in a number cycle. Now, we are going to use some examples to illustrate it so that you understand it better. Let's look at the first example. In a particular region, there are 4 markets. A, B, C, and D. Each of these markets are assigned the values below. A is 3, B is 0, C is 1, and D is 2. Question that arises from here. 1. Which market was held 7 days after market B? Which market was held 7 days after market B? Then another question that comes from here. Which markets day was held 10 days after market D? Now, in a particular region, there are 4 markets, A, B, C, and D. Each of these markets are assigned the values below. A is 3, B is 0, C is 1, and D is 2. Now, first, before we proceed, consider that there are how many markets? 4. So, whatever we are doing, we are going to do concerning this question is surrounding these 4 markets. So we speak of mode 4, or we say modulo 4, or modulus 4. The shorter form is mode 4, modulo 4, or modulus 4. Any of these expressions you use is acceptable. Now I take it again. Since all what we are doing here is surrounding, we are going to answer surrounding these 4 markets, we'll speak of mode 4. Now, the first question says, which market was held 7 days after market B? After market B. Market B is what? 0. Market B is 0. So the market that was held 7 days after market B. So that will be 0 plus the 7 days, which gives us what? 7. Now remember, we are discussing in terms of mode 4. So what do? We say 7 divided by 4. We say 7 divided by 4. That will give us 1 remainder what? 3. 1 remainder 3. So it therefore means that 0 plus 7 is equivalent to what? 3. We pick the remainder. This is where we are interested in. 0 plus 7 is equivalent to what? 3. And which market day is 3? It's A. So the market that was held 7 days after market B is market that was held 7 days after market B is what? A. Is market A. Without racking our head, calculating, start counting with our fingers. With modular arithmetic, we have been able to get the answer smoothly. Now let's use the same approach to answer the B question. The B question says, which market day was held 10 days after market D? Remember that market D is assigned what value? Market D is 2. So it is going to be 2 plus 10, which gives us what? 12. Now, since we are discussing in terms of mode 4, it's going to be 12 divided by 4. It gives us what? 3 remainder 0. 3 remainder 0. So, therefore, 2 plus 10 is equivalent to what? 0. In this one is mode 4. 0 in mode 4 always indicates the modulus that you are calculating on. So which market is 0? Of course, it is B. So the market that was held 10 days after market B, we will say the market is what? B. With modular arithmetic, get it. So where you are living, if you have several market days, know the number of market days. That becomes your modulus or modulo. Then, if a market day is held today, you can calculate exactly without making mistake which market day, after some few days, the market day will follow. You will know the exact market without racking your head using modular arithmetic. Now, there are some other practical examples for you to have. What you are doing now is an introduction for you to have a general idea of what modular arithmetic is all about. So let me clean this one now. Must have written it. Let's look at another example, which is example 4. If Mr. A goes to sleep at 11 p.m. and wakes up 8 hours later. At what time will he wake up? Yes, did I hear somebody say, it's simple now, we start counting with our fingers from 11, 8 hours later? Yes, you will get the answer. However, do you know you can use modular arithmetic to get it without sweating? Now, you know our clock system is basically a 12 hours interval. That's our clock system. So we speak of mode 12. We are going to work using mode 12 because of our clock system. So at what time did he go to sleep? He goes to sleep 11. How many hours later is he expected to wake up? 8. So 11 plus 8 is what? 19. Now, this will now be 19 divided by 12, because you are working with mode 12. Our clock is 12 hour system. So we are working with mode 12. So how many 12 are inside 19? Because that's 1 remainder 7. So therefore 11 plus 8 is what? What is the remainder? 7 in mode what? 12. So the man will wake up at 7 a.m. Okay, let's count it with our finger now. The man sleeps 11 o'clock. 12. We are going to count 8 hours later. 12, 1, 2, 3, 4, 5, 6, 7. So you see it, 7. He wakes up 7, and that's exactly what we have here. Is it not easy? Yes. Let's look at the last example for today. Let's look at the last example for today. An aircraft leaves London at 11 a.m. to fly to Cape Town. The journey took 23 hours. What is the scheduled time? Of arrival. An aircraft leaves London at 11 a.m. to fly to Cape Town. The journey took 23 hours. What is the scheduled time of arrival? Oh, did I hear somebody say, hey? The same approach. Don't be scared. Let's look at the solution to it. What time did he leave? What time did the aircraft take off? 11. How many hours did it fly? 23. So 11 plus 23 is what? 34. Now remember, our clock is a 12-hour system. We are working with mode 12. So 34 divided by 12 will go 2 remainder 10. So it therefore means that 11 plus 23 is equivalent to what? 10. In mode what? 12. So the aircraft will arrive at 10 a.m. the next day. If you use your fingers to count, you will discover that that is what is going to happen. Or if you place clock in front of you and use it to count it, you will arrive at this value exactly 10 a.m. the next day. That is the answer. So that is how practical modular arithmetic is. Just as we have seen, it is an arithmetic. So we will do addition in modular arithmetic. How do we add? How do we subtract? How do we multiply? And how do we divide in modular arithmetic in subsequent videos. So thank you very much. I hope with the way we have explained this, you will not find this topic scary again. Please press the subscribe button. See you in our next video. Thank you very much.